If the medieval warm period really was hotter than today, as the skeptics said, it would support the idea that global warming is just part of the climate's natural cycle. The historical evidence seemed to back up the claim. But what scientists needed was hard data. They needed to know what the temperature really was 1,000 years ago in the medieval warm period. In the 1990s, a scientist called Michael Mann took on the task. But he faced a major challenge.
It's not easy. We have instrumental records on a widespread global basis, really for only at most the past century. Then maybe back into the mid-19th century, enough instrumental data to say something, for example, about the average temperature of the northern hemisphere. But by the time you go farther back, there are very few instrumental records.
With no thermometer records, Michael Mann needed something that could act like a natural thermometer. Something that would provide data going back centuries. And this is where he found it. I'm in the White Mountains in California, and this area is a real mecca for scientists studying past climate. That's because this is no ordinary forest. It's home to the oldest living things on the planet. These trees live for thousands of years. They're called bristlecone pines, and they're found only in a few small areas of the western USA. This is strangely wonderful. It feels as if it's oozing out everywhere. Mind you, I'm a bit surprised, considering how old it is. You'd think it was much bigger. I guess it shows its age in other ways. I mean, look at this weather-beaten and gnarled texture. I'm told that this one's about 2,000 years old, but some of the trees are over 4,000 years old. I mean, when they were saplings, my ancestors were living in straw huts. Stonehenge was modern architecture. It really stretches your mind. These were just what Michael Mann was looking for, because inside they contain a record of past temperatures. Like any tree, these pines lay down rings, one for each year of their life. These rings are the key to past climate. This is a slice from one of the trees. Take a look. You can barely see the tree rings. They're in there all right. They're just really tightly packed. And the reason that each ring is so fine is because the tree grows a tiny amount every year. That is 100 years. And it's these rings that tell us about past temperatures because they tell us how much the tree grew in that year. In a warm year, the snows will melt earlier and the trees will grow more and leave a fatter ring. In a cold year, they'll hardly grow at all. It's called a climate proxy. You can't read temperature directly like reading it from a thermometer, but you can use the evidence to estimate what the temperature was. But of course this only tells you about the conditions in this one place. So Michael Mann and his team needed to find other temperature proxies from all around the world. Places that could tell them what the temperature really was as far back as the medieval warm period. They searched the world getting data from other proxies, like corals from the Red Sea and ancient layers of snow from the mountains of Peru. And then they had to add in the recent thermometer records. You can Combining the different numbers to reconstruct global temperatures is a fiendishly difficult task. It needs the kind of statistical analysis that makes my head hurt.